Welcome to the third session in which we'll talk about networking media. For data to travel from one point to another, it has to pass through some form of medium. In this session, we examine the media through which networking can take place and their characteristics. At the end of this session, there are a number of things you should be able to do, defining voltage, resistance, impedance, current, etc. Be able to understand multi-mode and single-mode fiber, how fiber is installed, discuss safety issues related to fiber. We would cover some of the key topics would involve copper media, optical media, and wireless media. The work on optical media will be left to you as a reading assignment for you to do. The reading list is shown in this slide, and I recommend that you look at them. Copper is the most widely used form of media. Optical fiber is most frequently used medium for longer, higher bandwidth, point-to-point transmissions, which is required on LAN backbones or on WANs. Optical media uses light to transmit data through thin glass or plastic fiber. Wireless is also becoming very popular. Currently, wireless technology does not provide the high-speed transfers that is required, the security or uptime reliability of cable networks. However, the flexibility of wireless has justified the trade-off. A simple wireless network could be up and working in just a few minutes. So connectivity to internet is actually provided through a wired connection or an access point. Let's first look at copper media. Many different types of copper cable are available. Each type has its advantages and disadvantages. The proper selection of cabling is key to efficient network operation. Since copper uses electrical currents to transmit information, it is important to understand some basics of electricity. The protons and neutrons are combined together in a small group known as what? Nucleus. Atoms or groups of atoms called molecules can be referred to as materials. Materials are classified into three groups based on how easily the free electron flows through them. This includes like insulators, conductors, and semiconductors. Voltage is sometimes referred to as electromotive force, yes, EMF. EMF is related to an electrical force or pressure that occurs when electrons or protons are separated. Voltage can be created in three other ways. The first is by friction or static electricity. The second way is by magnetism or an electric generator. The last way that voltage can be created is by light or a solar cell. Voltage is represented by the letter V and sometimes by the letter E for electromotive force. The materials through which current flows vary in their resistance to the movement of the electrons. So the electrons just don't freely flow, but the material presents some resistance to them. Impedance includes resistance, capacitance, and inductance, and is similar to the concept of resistance. Attenuation is important in relation to networks. Attenuation refers to the resistance to the flow of electrons and explains why a signal becomes degraded as it travels along the conduit. The letter R is used to represent resistance. We measure resistance using ohm, a Greek letter, omega. Current flows in closed loops called circuits. These circuits must be made of conductive materials and must have sources of voltage. The relationship between voltage, resistance, and current is given as V times equals to I R, or V equals to I times R. The product of our current and resistance equals to voltage. There are two forms of flow of current. That's alternating current and direct current. An alternating current voltage changes their polarity or direction over time. A DC always flows in the same direction, and DC voltages always have the same polarity. a battery, common battery is an example of a that produces direct current, DC. One terminal is always positive and the other terminal is always negative. You do not change or reverse these terminals, else you will damage your appliance. Cables have different specifications and expectations. Important considerations related to performance are as follows. What speeds for data transmission can be achieved with that cable? Will the transmission be digital or analog? Digital or baseband transmission, and analog or broadband transmission, all of them require different types of cable. How far can a signal travel before attenuation becomes a problem of concern? The following Ethernet specifications relate to cable types. So there's 10 base T, 10 base 5, 10 base 2, etc. Now, the 10 base T refers to the speed of transmission at 10 megabits per second. The type of transmission is either baseband, so the base tells you baseband, or digitally interpreted. The T stands for twisted pair. So if you take 10 base 5, that also refers to the speed of transmission at 10 megabits per second, and the 5 tells you that it can become what? It can travel 500 meters before, attenuation becomes an issue. The 10 base 5 is often referred to as a thicknet. Why is it called thicknet? Coaxial cable consists of a copper conductor which is surrounded by a layer of flexible insulation as shown in the diagram. So there's a central conductor, there's a shield, a foil shield, and there's a braided shield, and then there's an outer jacket. For LANs, coaxial cable offers several advantages. It can run longer distances than shielded twisted pair, and shielded twisted pair, and the screen twisted pair without the need for repeaters. The largest diameter was used as an Ethernet backbone cable since it has greater transmission lengths and noise rejection characteristics. One disadvantage is that coaxial cable is more expensive to install than twisted pair cable. STP cable combines the techniques of cancellation, shielded and twisted wires. It is used in token ring network installations. STP reduces electrical noise within the cable, such as peer-to-peer coupling and crosstalk. STP also reduces electronic noise from outside the cable, such as electromagnetic interference and radio frequency interference. The cable that connects from the switch port to the computer, there's a NIC port, is called a straight-through cable. So you know that you have to connect your computer to the network or other devices. Now, the cables used to do the connections are special cables. So the one that connects from the switch port to the computer is called a straight-through cable. The cable that connects from one switch port to another switch port is called a crossover cable. And the cable that connects the RJ45 adapter on the COM port of a computer to the console port of a router is called a rollover cable. You must be able to distinguish between all these cables and be able to identify them. You should see this in the lab. The various types of cables, you should see them in your lab sessions. Light is used in optical fiber networks. It's one type of electromagnetic energy. When an electric charge moves back and forth or accelerates, a type of energy called electromagnetic energy is produced. This energy, in the form of waves, can travel through a vacuum, the air, and through some materials like glass. An important property of any energy is a wavelength. For this, there are a number of important things you need to study, and this is left for you as a reading assignment. So I want you to look at electromagnetic spectrum, the ray model of light, reflection, refraction, total internal reflection, signals and noise in optical fibers, magnetic field of direct and alternating currents. Let's now talk about wireless media. Wireless is becoming an important transmission medium. Both copper and fiber media require that devices remain stationary, permitting moves only within the limits of the media. Wireless technology removes these restrictions. Understanding the regulations and standards that apply to wireless technology will ensure that deployed networks will be interoperable. We will look at some of the regulations and standards that apply to wireless technology. First of all, you need to know that the end user devices that provide users with a connectivity to the network are called hosts. The IEEE is the prime issue of standards for wireless networks. A key technology contained within the 802.11 standard, which is the standard for wireless standard, is direct sequencing spread spectrum. DSS applies to wireless devices operating within 1 to 2 megabits per second range. The next standard was a 802.11b, which increased the transmission capabilities to 11 megabits per second, and it's also known as a Wi-Fi. The 802.11a covers wireless LAN devices operating the 5 gigahertz transmission range. The 802.11g provides the same bandwidth as 802.11a, but with backwards compatibility. A wireless network may consist of as few as 2 devices. The nodes could simply be the desktop or workstations or notebook of computers equipped with wireless NICs, network interface cards. You can then establish an ad hoc network, which compares to the peer-to-peer wired network. Although it does provide connectivity, security is at a minimum along with throughput in such networks. Another problem with this type of network is compatibility. Let's look at some of the devices and topologies in wireless networks. An access point is also commonly installed to act as a central hub for wireless LAN infrastructure. So apart from the 2 wireless devices communicating directly, you can have an access point or a hub through which the devices can communicate or establish communication. Wireless access points are normally equipped with antenna and provide wireless connectivity over a specified area referred to as a cell. So the cell is the area within the coverage area of the antenna. To service larger areas, you might need multiple access points, and this may be installed with some degree of overlap. When a client is activated within a wireless LAN, what it does is to start listening for a compatible device with which to associate, that's to pair, associate. This is referred to as scanning and be active or passive. Active scanning uses a probe request to be sent from the wireless node seeking to join a network. When an access point with the same SSID is found, the access point will issue a probe response. Now, the authentication association steps are then completed. Passive scanning, on the other hand, allows nodes to listen for beacon management frames, or beacons, simply known as beacons, which are transmitted by the access point. When a node receives a beacon that contains the SSID of the network it's trying to join, an attempt is then made to join the network. Wireless authentication occurs at layer 2. It is a process of authenticating the device, but not the user. So, unlike in our wired networks that we've been discussing previously, authentication is of the device, but not the user. Authentication may simply be a null process, as in the case of a new access point and a NIC with default configuration in place. It is critical to point, it's a critical point to remember when considering wireless LAN security, troubleshooting, or overall management, that there is this null authentication. Unauthenticated and associated. The node is going to, when you become unauthenticated and unassociated, the node is disconnected from the network and not associated to an access point. In authenticated and unassociated, the node has been authenticated on the network but has not yet associated with the access point. Authenticated and associated, the node is connected to the network, able to transmit and receive data through the access point. So there are a number of configurations here. You can be unauthenticated, unassociated, you can be authenticated, unassociated, and you can be authenticated and associated at the same time. This is the condition that will normally apply when you want to work with the network or use the network. The IEEE 802.11 lists two types of authentication processes. The first authentication process is the open system. This is an open connectivity standard in which only the SSIDs must match. The second process is the shared key. This process requires the use of what? Wired equivalent privacy, or the web encryption method. Let's look at radio waves and modulation. Computers send data signals electronically. Radio transmitters convert these electrical signals to radio waves. In a wireless LAN, a radio signal measured at a distance of just 10 meters, that's about 30 feet from the transmitting antenna, would only be about 1/100th of its original strength. Now, this is quite important. Think about your mobile phones, the distances over which you can transmit or talk to people. You can talk to someone who is in the UK, or you're in Accra, the person is in Tamale, over that distance. And if you're saying that the signal can be just 1/100th at just 30 feet, then how much power do you need in order to what? Send a signal a long distance? It means that this might mean that you require very huge, amounts of power. But that is not the reality. Why? What methods do they use? What schemes do they use to ensure that you can send these signals over long distances without consuming huge amounts of power? Now, the process of evaluating a location for the installation of a wireless LAN is called site survey. And this is something that, as a wireless designer, systems designer, you would often be called upon to do a site survey, to find out what the signal strengths would be in that area to enable successful communication. Because radio waves signals get weakened as they travel from transmitter, the receiver must also be equipped with antennas. So not only the transmitter has an antenna, but the receiver also would have an antenna. The process of altering the carrier signal that would enter the antenna of a transmitter is called modulation. So what happens is that you really do not directly put your signals on the carrier as it is, on the transmitter as it is, but you actually modulate it. And it's key important here for you to find out about modulation, what it is, and how it is done. There are three basic ways in which a radio carrier signal may be modulated. I'll just briefly mention them: amplitude modulation, frequency modulation, and then a phase modulation. Where wireless networks already exist, there's little security. A number of new security solutions and protocols, such as the virtual private networking and extensible authentication protocol, are emerging. Some examples of these protocols are EAP-MD5, Challenge, the LEAP Cisco type protocol, user authentication, and then encryption. This brings us to the end of this session, where we have looked at copper media, optical and wireless media. Thank you.